Let us read the following question. Runs scored by two teams A and B on first 60 balls in a cricket match are given here. Represent the data by frequency polygon on the same graph. Before drawing the frequency polygon, let us try to analyze the data which is given to us. We can see that there are gaps between the upper and the lower limit of two consecutive classes. For instance, first class starts with 1 and ends at 6, while the second class starts with 7 and ends at 12. So any value between 6 and 7 is not included in the data. Also, to draw the frequency polygons, we need class marks, which is given by upper limit plus lower limit by 2. Now the question arises whether we should convert the class intervals to the continuous class intervals, or shall we calculate the class marks without converting the class intervals to continuous ones. Let us do the question both ways and conclude later. We are finding class marks without converting the data to a continuous data. So we get 6 plus 1, 7 whole by 2, which is equal to 3.5. Next we get 7 plus 12, that is 19. So class mark is 19 by 2, which is equal to 9.5. Similarly, we complete this column of class mark. Also, while drawing the frequency polygon, we would require a preceding class to the first class. So let us take that to be minus 6, 0, and the successive class will be 61 to 66, because class width is 6 for all the class intervals. Then the corresponding frequencies will be 0 and corresponding class mark will be minus 3 and 63.5. Let us do the same question by making the intervals continuous. For that, we find the difference between the upper limit of one of the class and lower limit of the succeeding class. Clearly, the difference is 1. Then we have to add half of this difference, that is 0.5, to each of the upper limit and subtract same from the lower limit. Then our class intervals become 0.5 to 6.5. Again subtracting 0.5 from the lower limit and adding 0.5 to the upper limit, we get 6.5 to 12.5. Similarly, we can complete the whole column. Now our data becomes continuous. 0.5 to 6.5, 6.5 to 12.5, 12.5 to 18.5, and so on. Let us now calculate class mark for this continuous data or the continuous class interval. We get 0.5 plus 6.5 whole by 2, which is 7 by 2. So the first value is 3.5. Next one will be 6.5 plus 12.5 whole by 2, which is equal to 19 by 2. That is equal to 9.5. Similarly, we can complete the whole table. Now let us compare the two tables, that is the table we have without making the class intervals continuous and the table we get after making the intervals continuous. We can see that class mark do not change. Corresponding to 1 to 6, class mark is 3.5, 7 to 12 is 9.5, and class mark corresponding to 0.5 and 6.5 is 3.5. 6.5 to 12.5 is also 9.5, and so on. So that means the class intervals do not change even though we have changed the class intervals to the continuous ones. Hence we conclude to draw a frequency polygon of data with non-continuous class intervals need not make the intervals continuous. Just calculate the class mark and plot the graph. Also, we should note that in the given question, class width was same for all the class intervals. Now it's time to plot the graph. We can use any one of the table. Let us use the first one. Our data ranges from -3 to 63.5 and most of the entries have decimals in them. So firstly we should decide the scale on the x-axis as we are going to plot class marks on the x-axis. Let us take 1 centimeter equal to 5 units on x-axis and frequency for team A and team B have maximum of 10. So we can take 1 centimeter equal to 1 unit on y-axis. Let us draw the graph. Once the graph is ready, it only remains to plot the points for team A and team B separately and draw the polygons. Since we have taken 1 centimeter equal to 5 units on x-axis, so each millimeter will represent 0.5. Now our first point for team A is 3.5 and 2, which can be easily plotted. 9.5 and 1. Hence we will get a frequency polygon for team A. Similarly, plotting the points corresponding to team B will give us a frequency polygon for team B. Once we draw frequency polygon for team B also, we have completed the solution to the given question.